So, okay. Here we go. Inverse functions. So this is totally switching gears, not reciprocals, inverse functions. Okay, so the first thing I'll say is this. If I take the sine of x and raise it to the negative first power, that is different than y equals inverse sine of x. We understand hopefully that notation. Inverse kind of looks like it's raising something to a negative first power, but that's not really what's happening. This one is raising the sine to the negative first power, so this one is 1 over sine x, and so this one is the cosecant x. So this is not an inverse function. This is, in fact, a reciprocal function that we just spent time on, right? An inverse function is different. This is kind of in the ballpark of you switch all the x and y values and you're dealing with reflections over the line y equals x and all the inverse stuff that you did last year. Are you with me? Okay. So if I take the parent sine graph, so I'm going to make this 0, pi, and 2 pi. Negative pi, negative 2 pi. And I'm not graphing the inverse sine first. I'm just going to graph the sine curve. So I'm going to call this, I'm going to call 5 units equivalent to 1. You'll see why in a second. And I'm just going to graph the parent function of sine. Are you feeling nervous? No. What'd you say? Okay. Yeah. Yeah, and there are a lot of them with sine, cosine, and tangent. You got all the original graphs, you got all the reciprocal graphs, you've got inverse graphs, and so on. Okay, so if I invert this function in its entirety, will the inverse be a function? Why not? Right, so our original sine graph fails the horizontal line test. So our inverse function would fail the vertical line test and therefore wouldn't be a function. Okay? And that's really the big reason behind why we're about to do what we do. When we go to write and think about the inverse function of sine, we're only going to pick a certain stretch of the graph that passes the horizontal line test. Namely, we're going to pick this section right here, which is between what x values? Right, so when we look at the sine curve, we're going to only look at x coordinates that are between negative pi over 2 and pi over 2. And our y coordinates are between what and what? Negative 1 and 1. So when we go to graph the inverse function, what's our domain? Negative 1 to 1, because they flip-flop. And what's my range? And this here is the big reveal that we'll keep coming back to. When you're asked for the inverse sine of a number, your answer has to be between negative pi over 2 and pi over 2. What quadrants are those? One and not 3, between negative pi over 2, which is here, to positive pi over 2, which is here. Quadrants 1 or 4. Okay? So if you are asked for, and we'll go down to the example below. We'll go back up to that graph in a minute because we're not done with that. Well, we go down to an exact value. The inverse sine of root 2 over 2. Our answer has to be an angle that is in quadrant 1 or quadrant 4. There is an angle in quadrant, well, all students take calculus. When you're asked for the inverse sine of root 2 over 2, you're essentially being asked the sine of what angle equals root 2 over 2. That's really what you're being asked. It's to kind of think backwards. Here's the sine value. What is the input that goes with that? Now, technically, we have answers because sine is a positive root 2 over 2. If the question was posed in this way, if it originated in this way, we would have a gazillion answers. We'd have an angle in quadrant 1 that has a positive sine value. We'd have an angle in quadrant 2 that has a positive sine value, and your terminal ray could keep going around and round and round an infinite number of times. So this, when the question is presented in this fashion, we do have an infinite number of answers. But when it's presented in this fashion and you're just asked what is the inverse sine of root 2 over 2, you have to give the angle in either quadrant 1 or quadrant 4. So which quadrant is it? Because sine is positive. 1. And specifically, what is the angle measure in quadrant 1 that has a sine of root 2 over 2? 45 degrees, or radian measure of pi over 4 is going to really be where we go with this, because this is a radian, going to be in radians. Okay? By the way, what I just explained to you as far as if the question originated this way, you'd have an infinite number of answers. Since the question actually was this one, you have to stay in quadrant 1 or 4. Reminds me of this idea. You know when you're asked, if someone says, what's the square root of 64, what do you tell them? 8. But if someone says, what squared equals 64, what do you tell them? Plus or minus 8. Kind of the way the question originates is important. Do you see the parallel I'm trying to draw here? Okay, it reminds me of that in a way, knowing that these kind of are the same question, but they are different, and there's a technicality as to why they're different. Same thing here. This and this are kind of the same question, but there's a technicality because this one technically has infinite solutions. This one has to give you an answer in either quadrant 1 or 4. And the reason behind all of that comes back to this idea of the inverse and only being able to invert something that passes the horizontal line test. Are you with me? Okay? So let's just list the critical points in this stretch of the sine curve. We have, you already said, negative pi over 2, negative 1, 0, 0, and positive pi over 2, 1. Is that fair? So when we are graphing the inverse function, what are our critical points? Negative 1, negative pi over 2. Yep. 0, 0. 1 pi over 2. Now, this is going to be obviously a little bit tricky because for the sine parent graph, my x-axis is labeled with pi's and my y-axis is labeled with just integers. And if you're trying to graph the inverse, you got to kind of flip-flop your scales, which is difficult, right? So for the sake of keeping our scale as it was, where is negative 1 approximately? So here's negative pi. That's negative 3.14. So negative 1 is here-ish, right? What is negative pi over 2 as a decimal? Negative 3.14 divided by 2 is negative 1.57-ish. So that's going to be like something down here. And it's also going to be difficult to see, and I might just open the book and kind of show you this rather than trying to do it here, because these are going to be reflections across the line y equals x. But the perfect diagonal here is not y equals x because my scale on the x-axis is different than my scale on the y. Are you making sense of that, how this is a little bit tricky? So just for the sake of time and not being overly, crazy about getting those scales to be the same so we can actually see the reflection, I'm just going to show you in the book. No sense in reinventing the wheel. Here is the sine curve that we just drew. Okay, just the section of the sine curve that we want. And see how their scale is pi's on the x's and 1's to negative 1's on the y's. Here's the inverse sine. They had to switch the scale. The x's went from negative 1 to 1, and the y-axis went from negative pi over 2 to pi over 2. And we could do that, but it's just easier to show it to you here. Does that make sense? Okay? And then they go ahead and they put them on the same graph together, which would take some time and scaling. It's not really worth the time because we can just see it here. You see the reflection over the line y equals x. Okay? Does that make sense? So for lack of, time and patience for all that would go into that, I just wanted to show you that. So maybe kind of looking back, it would be better to just graph y equals sine inverse of x. So I'm going to get rid of this. It was the exploration of inverting the sine graph and all those pieces that would play into it. I'm just going to go from negative 1 to 1 on my x-axis because that's my new domain, and negative pi over 2 to positive pi over 2 on my y-axis. So now graphing my critical points for the sine inverse, negative 1, negative pi over 2, 0, 0, and 1 pi over 2. And you kind of got to know the bend of this graph a little bit. It's going to go up like that. Whereas the sine graph would do something like that if you want to see it lightly on the same thing. So I really lightly did my sine section in there. Steven. But it's hard to draw the line y equals x when your scale on your x coordinates is counting by 1s and this is counting by pi's over 2. Because it's not like the perfect diagonal anymore because your scales are different on each axis. So that's why we couldn't really go that route. So if you look at this one in the book where they show them on the same, they use negative 1 to 1 and negative 1 to 1 on both, and then they kind of placed where pi over 2, which is 1.57, would be slightly after each of those, which made them able to do both. Okay, Josh. Here's the sine parent graph. So minimum to maximum. There's the section of the sine graph that passes the horizontal line. No, and then they're kind of overlapping. The book is in color. This one's blue. There's our inverse sine, and this one's red. Okay? The big takeaway that I said in the beginning, I debated, do you want to know it first? The big takeaway is that inverse sine values have to be between negative pi over 2 and pi over 2, which is in quadrants 1 and 4. That's the big takeaway. All the rest of this is kind of the reason around it, and you should know what the parent graph of this looks like and to be able to think through that. Stephen. Well, I come up with the critical points of just the section of the sine graph that passes the horizontal line test. So I have those critical 3 points, and then I just flip them all. Nope, it's just that section. We can't repeat it. It's just you're always only looking in that interval from negative pi over 2 to pi over 2. We're not talking outside that interval because the inverse of sine does not exist outside of that interval, because the sine graph outside of that interval will fail the horizontal line test. Okay? So these are the kind of questions where you're going to constantly have to think about that. Inverse sine of negative 1/2, we have to find the angle within quadrant 1 and 4 is we're only limited to those two quadrants. Where is the angle that has a sine value of negative 1/2? Is it in quadrant 1 or 4? 4. And so what is the fourth quadrant angle? And then we can kind of think of this. What x value has a sine of negative 1/2 in the fourth quadrant? 330. So this is between negative 90 and 90, though, if you're thinking degrees. So we would go with the negative version of that angle. You don't have to turn the angle to be positive. In fact, you don't want to do that because that's out of interval. Okay? So it would be a 30-degree angle or a pi over 6 reference angle. So it's just negative pi over 6. The value of this is negative pi over 6. Okay? So you definitely want to memorize this. Know that anytime you see inverse sine, you're only limited to quadrants 1 and 4. And it's the negative quadrant 4 angle. It's not what Jalen just tried to do, the positive 330. Okay? So you want to memorize that. The reason behind it, I explained. But the likelihood of you thinking through that logic every time is not realistic. Just you have to kind of take that as fact moving forward and use that and know that inverse sine has to be between negative pi over 2 and pi over 2. Okie doke? Okay? And then there's the cosine. So let's kind of do a similar activity to kind of think about what quadrants the inverse cosine is limited to. So I'm just going to sketch it off the graph. Here's my cosine parent graph. And we can extend that. Sorry. So where is the section of the cosine parent graph that passes the horizontal line test? Zero to this section here, right? 0 to pi. So the only domain we're looking at on the parent graph is from 0 to pi. The range, again, is between negative 1 and 1. So when we get to our inverse cosine graph, it's a pi. What's our domain? Negative 1 to 1. And what's our range? Most importantly, 0 to pi. So what quadrants are those? 1 and 2. So anytime you're asked for an inverse cosine, you have to tell the angle that's either in quadrant 1 or quadrant 2. One of which has a positive cosine, one of which has a negative cosine. So you're covered. If we jump down to that first example, the inverse cosine of negative root 3 over 2. So essentially we're being asked the cosine of what angle equals negative root 3 over 2. But we can only give an angle measure. Our answer to this has to be in quadrant 1 or 2. Which quadrant is it? 2, because cosine is negative, and that of the two quadrants we're limited to, that would have to be quadrant 2. And what is the reference angle that has a cosine of root 3 over 2? 30 or pi over 6, right? Okay, so what is the angle in the second quadrant that has a reference of pi over 6? Not degrees. 150 has a reference of 30, yes. I want the radian measure of that. What is this that has a reference angle of pi over 6? 5 pi over 6, because this is 6 pi over 6. And so one tick before that would be 5 pi over 6, and that's your answer, 5 pi over 6. There is a lot of intangible, not showable mental work here that you have to go slowly through. Okay, so when you're doing your homework and you can't remember, really the best thing that you should do is go back and watch the video and listen to me talk through this again, because I can't really document all the thoughts that just went into that process very well on paper. It's kind of mental thought processes, okay? I can say it out loud, but I'm not going to make you write sentences. So if you get to your homework this weekend and you're like, oh gosh, I have no idea how these answers are happening, go back, watch, rewatch these little sections to think this through. Jalen? Right, because this one has to be something between 0 and pi. 0 to positive pi. The other one was between negative pi over 2 and positive pi over 2. Yes. Okay? All right, and just quickly to draw the parent graph of this one, we'll go to our critical points of our cosine graph where, what's this point? 0, 1. What's this one? No. This is pi, so what's this one? Pi over 2, comma 0, and then this one is pi negative 1. So we're going to invert all those to get the critical points on our inverse cosine. 1, 0, 0 pi over 2, and negative 1 pi, so that we can sketch a quick graph of this. Remember, our domain is going from negative 1 to 1, so we're going to label our x-axis negative 1 to 1, and our y-axis 0 to pi really is all we need. So I'll do pi over 2 here and pi here. So when I sketch 1, 0, I'm here. When I sketch 0 pi over 2, I'm there. And when I sketch negative 1 pi, I'm here. So this is going to look like that. The book unfortunately doesn't show them on top of each other in this case, but as you can imagine, it would be similar. But here's your cosine section that we're allowed to invert, and there's the inversion of it. Okie doke. Josh. No. You're not really going to have to graph them at all, I don't think. I don't believe you're going to have to graph them at all. Okay? Now tangent. Let's think about our tangent parent graph. We have asymptotes at pi over 2 and negative pi over 2. And then this happens over and over and over again. So this one's pretty, I would say, even simpler to come up with the appropriate invertible domain. So this is y equal tan of x. What's the domain that's going to allow us to pass the horizontal line test? Negative pi over 2 to positive pi over 2. And your range is negative infinity to infinity. So when you invert this, your domain is going to be negative infinity to infinity. Oops, why did I use brackets around these? Nobody corrected me. And our range is going to be, right. So one thing to remember that makes your life maybe a little easier, what quadrants are those? 1 and 4 again. Sine and tangent are limited to the same two quadrants. It's only cosine that goes 1 and 2. Honestly, it boils back down to all students take calculus. If it was 1 and 4, cosine's positive in both of those, so you would never get a negative cosine, which we know is not. Because they go side, it's 1 and whatever is next to, adjacent to 1. You wouldn't go opposite. I mean, really the reason behind all of that is in the what passes the horizontal line test idea. But so let's, before we graph this, what are our critical points within this section? 0, 0's the obvious one. Could you give me at least one more to the right and one more to the left? What's halfway between 0 and this asymptote? Pi over 4, and what's the output for the tangent of pi over 4? 1. And if I go this direction, that's negative pi over 4 and negative 1. Right? We all know the tangent of pi over 4 is 1. It's easier than doing a pi over 6 or a pi over 3 angle and dealing with root 3 or root 3 over 3. So when we invert these, we're still going to have 0, 0. We're going to have 1 pi over 4, and we're going to have negative 1, negative pi over 4. What's also important to talk about with tangents is your asymptotes were at x equals pi over 2 and at negative pi over 2 as well. What is that going to say for asymptotes on our inverse graph? Right, they're going to be horizontal at y equals pi over 2 and y equals negative pi over 2. So when it comes to scaling my x-axis, or really my y-axis in terms of pi's, I'll do negative pi over 2 to pi over 2. That's reflecting my range. And as Liam just helped us with, we have horizontal asymptotes there. And I'll scale my y-axis, or my x-axis rather, from 1 to negative 1. And I'll plot those three critical points, 0, 0, 1 pi over 4, and negative 1, negative pi over 4. And this is what this is going to look like. And last but not least, down at the bottom, inverse tangent of pi over 3 is technically asking us the tangent of what angle equals root 3, but we're limited only to the first and fourth quadrants with tangent. So which quadrant are we in? 1, because tangent is positive, and the tangent of what angle equals root 3? Pi over 3 is our answer. Okay, I'm not thinking degrees at all. I'm seeing root 3 over 2. And I know that's a reference. I know I picked what quadrant because it's positive or the negative. Because it's negative, I know it's this quadrant. And then I'm thinking a reference angle of pi over 6. So if that reference angle is pi over 6, how far away from, like, what would that be if this is 6 pi over 6? It's 1 pi over 6 prior to that. 5 pi over 6. Okay? So, I know you don't love this, but a lot of intangible thought that goes into this. I can't stress enough, rewatch the video sections when you need a reminder.